Well, hello everybody. A lot of sickness going around. We had 4 or 5 gone in class the other day, so I thought I might make a video to show you what we did. What I did last time is I gave you back and went over the test. So if you'd like to see your test score, it is in Power School. You can always pop in and I'll show it to you. Today's a very long day. I want to say I have about 56 class examples to go over with you. So kind of 3 different switches, so you'll have to hang with me and go from there. We go from negative exponents to multiplying to how to manipulate them. So hang with me, have your class example sheet right there in front of you, and we'll go from there. But here's where we started. I had the students grab their calculator and type in 2 to the negative 1. Well, once they did that, their calculator said 0.5. Well, I don't want to look at things as a decimal today. 0.5 is another name for 1/2. So please notice that 2 to the negative 1 is the exact same thing as 1/2. And then we did that for number 2. I had them type in 2 to the negative 2nd. That, as a decimal, came up to be 0.25. As an answer, though, this come up to be 1 over 2 squared, which is 1/4. And then I had them do the same thing with 2 to the negative 3rd. I had them type that in, and as a decimal, it come out to be 0.125. But the answer we want to look for today is 1/8. But I want you to also notice that 1/8 is the same thing as 1 over 2 to the 3rd. So that's where I'm going to go with today for a little bit. Then I had them do the same thing for 10 to the negative 1. When we did that, that became 1 over 10. When we did 10 to the negative 2nd, that came out to be 0.01, which is 1 over 100. Or, I'm going to write it like this because I want you to see something. 1 over 10 squared. And of course, we did 10 to the negative 3rd, and that came out to be 1 over 1,000, which is the same thing as 1 over 10 to the 3rd. So here's what I'd like for you to notice so far. When we work with negative exponents, if you see a negative exponent, you can get rid of that negative exponent by placing it in the denominator. So 2 to the negative 1 was the same thing as 1 over 2 to the positive 1. 2 to the negative 2nd was the same thing as 1 over 2 squared. To get rid of this negative, notice I just place it in the denominator and then change the sign. When you look at 2 to the negative 3rd, that wound up being 1 over 2 to the 3rd. So here's all you got so far. If you're working with the negative exponent, we're going to put it in the denominator. So if you see something like x to the negative 3rd show up, that's going to be the same thing as 1 over x to the 3rd. That's all there is to it. But what if the denominator is in the, what if the negative exponent is in the denominator? Well, I had the class type in their calculator 1 divided by 2 to the negative 1. Well, this came out to be 2 to the 1st, which is just 2. This came out to be 4, which is 2 squared. And this came out to be 8, which is also 2 to the 3rd. So here's what I need you to notice. Notice that when we had a negative exponent, if we want to get rid of it, put it in the denominator. If it's already in the denominator, bring it up. So here's a rule for you to put down. It's called our negative exponent rule. If I have any base in the whole wide world, which I'm just going to call a, to the negative m, I'm going to think of that as 1 over a to the m. A could be any base other than 0 that I want to work with. Kind of on a side one of that, if it's already in the denominator and it's got a negative exponent, I can bring that up and think of it like that. So I might have you a little confused right now. You won't be, hopefully, after these next few examples. So here's my number 10. Don't try to do these in your calculator. We may run a little bit of it through your calculator, but mostly we're going to do it in our heads. 3 to the negative 1 is the same thing as 1 over 3 to the 1st. But 3 to the 1st is 3. So to get rid of the negative exponent, put it in the denominator. Number 11, 5 to the negative third is the same thing as 1 over 5 to the third. Now you might grab your calculator, but the only thing that I want you to type in is the 5 to the third part. That's 125. So to get rid of our negative exponents, put it in the denominator. 4 to the negative fourth, that's the same thing as 1 over 4 to the fourth. And if you grab your calculator and go 4 caret 4, or 4y to the x4, that's going to give you 256. If you got a negative exponent, we place it in the denominator. If it happens to be a negative number, keep your parentheses for a little bit. So parenthesis, negative 2 to the negative 1, this becomes 1 over negative 2 to the positive 1, which is negative 1/2. Negative 2 to the first is negative 2. But if I got negative 2 to the sixth, this becomes 1 over, keep your parentheses for a second, negative 2 to the sixth, which becomes 1 over. Now you could grab your calculator and go 2 to the sixth and get 64. Negative 5 to the negative third, I'm going to think of that as the opposite of 1 over 5 to the third, which is negative 1 over 5 to the third is 125. So there's where we're at so far. Now look at number 16. Just remember this rule. If you see a negative exponent, place it in the denominator. So I'm going to think of this as a to the first, b to the negative second. If there's no exponent there, it's a 1. So when I write this answer, the a has a positive exponent, so leave it alone. Leave it in the numerator. But the b squared, I'm going to place in the denominator because it had the negative exponent. When I look at my number 17, I'm going to let this be my fraction bar this time. A to the third is positive, so leave it alone. B to the negative second, there's the negative exponent, drop it to the denominator. C to the negative 5, I said negative exponent, so move it down to the denominator. D squared's in the numerator, and it's positive, so leave it alone. So there we got it. Number 18, x is to the first power, so you're not going to move it out of the numerator. This y to the negative third, though, to get rid of that negative exponent, I'm going to bring it up. So here's my answer, x to the first, y to the third. Boom, there's my answer. So on negative exponents, just move them opposite wherever they are. Here's my number 19. I'll let this be my fraction bar again. I've got a, b to the negative second, c to the negative third. Well, a has a 1 with it. If there's no exponent, it's a 1. So it's positive, so leave it alone. That b to the negative second, to get rid of that negative exponent, I have to bring that down to the denominator. That c to the negative third, to get rid of that negative exponent, I have to bring it up. So there's my answer. So on negative exponents, just move them opposite wherever they are. 1 over x to the negative 7, to get rid of that negative 7 as an exponent, I'm going to bring it up out of the basement. So this becomes x to the 7th. Number 21, I got x to the 4th over y to the negative 9. The x to the 4th is positive. Leave that exponent alone. This one's negative. Move it up. Answer, x to the 4th times y to the 9th. All done. Now what I had them do on number 22 is I had them type any number in the whole wide world into their calculator and raise it to the power of 0. And everybody in the class, even though they might have used different numbers, came up with the same answer, which is 1. Anything to the power of 0 is 1. So with that being said, My number 23, I got a to the 0 over b to the negative third. Well, a to the 0 is 1. And I got that b to the negative third. Well, there's a negative exponent, so I'm going to bring it up out of the denominator. So I've got b to the third. There's my answer. Number 24, this becomes 8100 times, to get rid of that negative exponent, I'm going to bring that to the bottom. So now I've got 8100 over 16. You could simplify that in your calculator if you'd like. It comes out to be 2025 all divided by 4. So there's kind of my first part of the day, dealing with negative exponents. Moral of that story, if you got a negative exponent, just move it. If it's in the denominator, move it to the top. If it's already in the top, move it to the denominator. Now I'm going to switch gears on you just a little bit. I need to talk to you about multiplying monomials that has the same base. So x to the 4th times x to the 7th. You've seen this before in your Algebra 1 days. X to the 4th means that I have 4 x's multiplied together. Times another x cubed means I have another 3. So this really becomes x to the 1, 2, 3, 4, 5, 6, 7. Look at your number 2. A to the 6th times a to the 4th. It means that I have a times itself together 6 different times. And then I also have a multiplied 4 more times. Well, if you look at this, I have an a 10 different times. Well, I'm hoping right now you're thinking of a little shortcut. And hopefully you said, well, duh, all you're doing is adding the exponents. And that's part of the shortcut. And if you look at my number 3, I have a 2 times 3 x's. I have a 5 times 6 more x's. When I go to simplify this, 2 times 5 is 10, x to the, and if you add these up, you got 9. So you just figured out a shortcut if it's a monomial times a monomial. And what that is a to the m times a to the n means if your bases are the same, I don't care if they're a number or a letter or a quantity or an animal. If the bases are the same, all you have to do is add those exponents. So there's our second rule of the day. Down here it says other rules that still apply. If you see a negative exponent, shift it down to the denominator. If that negative exponent is already in the denominator, shift it to the numerator. Okay, so now we're going to apply some more rules. And like I said, leave your calculator alone. It's better off if you master this without your calculator, because your calculator is not going to help you with variables anyway. So 4 to the 3rd times 4 to the 5th, all I want for now then is for you to know that this is really 4 to the 8th power. And let's stop there for the day on that. That's just going to be 4, well that's an ugly 4, 4 to the 8th power. Now a lot of people said, no, Mr. Harris, 4 times 4 is 16, and you're right. But remember, this means I have a 4 3 times, and then I have another 4 5 times. Well, look at what you got. You got a 4, 1, 2, 3, 4, 5, 6, 7, 8 times. So your base never changes. 2 to the 5th times 2 to the 2nd, this becomes 2 to the 7th. I don't care what the answer is right now. I just wanted you to know the exponent part of it. 4 cubed times 4 to the 5th, this becomes 4 to the, add your exponents, 8. I'm going to click right through these. X to the 9th times x to the 11th. The bases are the same. Add your exponents, x to the 20th. Now guys, remember we're multiplying. So 4 times negative 3 is negative 12. B cubed times b to the 5th, add those exponents, and I'm going to get b to the 8th. Moving on to number 6. Negative 3 times negative 5 is negative 15. A to the, add your exponents, 12. That's all there is to it. Now, don't try to put this 15 in the denominator because it does have an exponent, but it's 1. So you can't touch that. Leave it where it is. Here's my number 7. I'm going to go 6 times negative 2 times 3, and I'm going to get negative 36. And then my bases are C, so to get my exponent of the C, I'm going to go 3 plus 6 plus 11 and get 20. And then we got it. Here's my number 8. I need to go 4 times 3 and get 48. Z to the 9 plus negative 6 plus 1. Because there's a 1 right here with this Z. So looks like that's going to be 4. So 48, Z to the 4th. If I get going too fast, you can always pause it and slide it back. But it's a long enough video, I was going to keep it clicking. Here's my number 9. I got 2x to the 5th, 5x to the negative 9, and 3x squared. Notice that there's 2 blanks here. I'll show you why. 2 times 5 is 10, times 3 is 30. X to the, add your exponents. 5 plus negative 9 plus 2 is negative 2. Well, now I got a negative exponent, so I got to get rid of that negative exponent. So this becomes 30 over x squared. We're going to do so many of these that as soon as you say a negative, you're going to go straight to the answer. Here's my number 10. Multiply your numbers, so multiply 4 times 2 times 10. Well, 4 times 2 is 8, times another 10 makes 80. Hey, notice I got different letters here this time. Big deal. I got an A base, so to get the A, I'm going to go 2 plus 1 plus 6 and get A to the 9th. B to the, add those 4 plus 6 plus 11 and get 21. And then I'm done. Here's my number 11. Negative 2 times 5, that's going to be negative 20. X to the 2 plus negative 9 plus 3 equal negative 4. When I do the y's, I got a 5 plus 2 plus 7, and that's going to give me 14. So I got a y to the 14th. But I have a negative exponent, so here's my ending answer. Negative 20 stays on top. Even though it's negative, it doesn't have a negative exponent. It's got an exponent of a 1 over x to the 4th. Here's what I hope you get doing. I hope you skip this step here. I hope that you can go negative 2 times 5 is negative 20. Then you go through and add your x's and you say x to the negative 4, so you automatically just do that. And then y you say is positive, so I hope you get to where you just get right to the answer. Now the rules aren't going to change here, but notice the exponents did. Do not be afraid because I threw fractions at you. You have a nice calculator, so we'll use it to do that. So number 12, 5t to the 1/2 times 9t to the 2/3. 9 times 5 is 45. You're going to grab your calculator and go 1 fraction key, 2 plus 2 fraction key 3, and you're going to get 7/6. If you got 1 1/6, you need to go second fraction key again, so it gives you 7/6. Number 13, 2 times negative 3 is negative 6. Now for your A, you're going to have to go 3 fraction key 2 plus 2 fraction key 3. So you would grab your calculator, type that in, pause the video if you need to, but you should get 13/6. B to the, you're going to go 5/6 plus 1/3 in your calculator and get 7/6. So the steps are the same. I just threw fractions at you. Big deal. Here's my number 14. 6 times -2 is -12. A to the -3/5 plus 1/3. If you type that in, you're going to get -4/15. So I hope that you realize that's got to go to the denominator here in a second. And then I'm going to go B. So I'm going to go 5/6 plus 4/3 and get 13/6. Ending answer, -12. There's a negative exponent, so it goes down here. That B has a positive exponent, so leave it up there. So that's kind of rolling on the next part. When you multiply, you just add your powers. I have a few more easy ones, and then I switch gears one last time. So here's number 15. I got the quantity a plus b to the 7th times the quantity of a plus b to the 5th. Hey, my base is still the same, a plus b. So when I do this, a plus b, add your exponents and get 12. All done. Here's my next one. X plus y, the bases are the same. Add your exponents and get a 4. All done. Here's what I'm looking for on number 17. I need you to fill in the question mark. And here's what I mean by the question mark. I got x to some power times x cubed, and my answer is going to be x to the 10th. I need you to figure out what the question mark is, so that when I multiply them, I get x to the 10th. Well, hopefully you already saw that. It's going to be 7. And here's how come. You know you're going to add your powers, so something plus 3 has got to be 10. That something's got to be 7. When I look at 18, y to some question mark times y to the -4th equals y to the -11th. Something minus 4 has got to be -11. To solve that, I'm going to add 4 to both sides, and I'm going to get -7. And then I just tossed in one last one, 1 over a to the 5th, a to the -11th. A couple of different ways to do this, but here's the way I'm going to attack it today. This becomes 1 over. We're multiplying, so add your exponents and get a to the -6th. But bring that up and get a to the 6th. So I got one more little piece for you. Looks like my video is right at about 23 minutes. I got another 5 to 6 minutes with you, and then you will have had the lesson by then. So go to your next little piece. I need to talk to you about what polynomials are, and then we're going to review, because we've been doing it, we're going to review on how to add, subtract them, maybe even multiply them. So if you will, add this to your paper. An expression is going to be a polynomial if the powers are the exponents, whatever you want to call them right now. The powers are the exponents are whole numbers. So there can't be anything weird looking. I can't have a variable in the denominator. So 1 through 6 are really, really easy. So hang with me for a second. It says, for each of the following, state if the expression is a polynomial. If it is, let me teach you how to give the degree of it. So here's number 1. I'm going to go look at the exponents. Here's a 2, here's a 1, here's a 1. There's no negatives. There's nothing weird looking on there. So yes, this is a polynomial. To get the degree, look at each term and then see which term has the highest power or powers. So in this number 1, it is a polynomial and it's a degree 2 because this term has a degree of 2, this has a degree of 1, technically this has a degree of 0. 2 is the biggest number out of all those, so it's a second degree polynomial. Number 2, to decide if it's a polynomial, look at the powers. I don't care about this 1/4 out front. I see a 4 and a 3 and a 5. They're all positive whole numbers, so yes, this thing is a polynomial. To get the degree of it, here's what I got to do. This first term has a 4 and a 3. Well, if you add the 4 and the 3 is 7, and if you add the 4 and the 3 together, you get a 7. This term only has a 5. Pick the bigger number. That's the degree of your polynomial. Number 3, it's not a polynomial. Why? I got this square root. That's coming up, but that would be a power of a 1/2. But anytime you see something weird like that, not a polynomial. Number 4, not a polynomial. The reason being, I have a negative exponent. You can only have positive whole numbers. Number 5, what do you think about number 5? Number 5 is a yes, because I see a 5 and a 1, a 4 and a 3, and a 1 and a 1. To get the degree of it, go to each term and add up the powers. 5 and 1 is 6, 4 and 3 is 7, 1 and 1 is 2. The biggest number out of those is a 7. And number 6, no, not a polynomial. The reason being, I have this in the denominator. If I was to rewrite that and bring it up, I would have to use a negative exponent. So that's what makes it not a polynomial. So hang on, I'm almost done. I'm just going to quickly review with you, because we did this with the i's. The concept's the same. Look in here, and you're going to see a plus sign between there. So go through and add up each of your like terms. So here's a plus sign. So find your 3x squared and your 2x squared, and then add those up. So 3x squared plus 2x squared is going to be a 5x squared. When you add or subtract, powers never change. Here's a negative 5 and a negative 3. Negative 5 plus negative 3 is negative 8x. And then 6 plus negative 1 becomes 5. We did these early in the year. I thought I'd just review them real fast with you. So find your like terms, add them up. If there's subtraction in there, make sure you're subtracting. I'm going to go 3x squared minus 2x squared. Well, 3 minus 2 is 1x squared. Now I'm going to go negative 5 minus negative 3. Notice that gives me a negative 2, so I've got minus 2x. And then 6 minus negative 1 becomes 7. Now I'm also going to show you another way. Some people don't like to mess with subtraction. If you don't want to mess with subtraction, just distribute this negative 1. So I'm going to have 3x squared minus 5x plus 6 minus 2x squared plus 3x plus 1. Now just go through and find your like terms. 3x squared and negative 2x squared make 1x squared. Negative 5 and negative 2 make a negative 7. Oops, so I'm glad I did it this way. Oh, no, it doesn't, because I distributed that. So negative 5 and negative 2 make a negative 7x. Oh, I caught myself in an error. And then 6 and 1 make the 7. Okay. So here comes another one. There's an addition, so nothing too fancy on that one. Here's a squared. Here's a squared. Negative 9 plus negative 3 is negative 12x squared. Here's an x. Here's an x. So 7 plus 11 is 18x. And I got a negative 1 in there. So there we got it. Then I got one more minus 1. So let me not mess this one up this time. I'm going to make things easy, let me distribute that negative. So I got 9x squared plus 7x minus 11x plus 3x squared plus 1. I just distributed this negative 1. Now go through and find your like terms. Negative 9 and 3 makes 6x squared. 7 and 3 make it 10x. And looks like I got a 1. So then we got it. Then it looks like I just got a couple more. Here's my number 11. Whoo, that looks like a mess. But it's not. Let me distribute for you. So I got 4xy squared plus 12xy minus 7x squared y minus 20xy, negative, negative, so plus 5xy squared plus 19. Hey, it looks like a mess, but go through and find your like terms. xy squared, got to be exactly the same. So I got 9xy squared. Here's a xy, here's a xy, so minus 8xy. I don't see another x squared y, so it's a loner, as is that 19. So there you got it. So find your like terms if it's addition or subtraction. The last three you'll like, they're multiplication, the distributive property, but we just apply the same rule. I'm going to distribute this, remembering when I multiply, I add powers. So 4x squared times 4x squared, that's going to become 16x to the 4th. 2 plus 2 is 4. Minus 12x to the 3rd. 2 and 1 made 3. Plus 28x squared. All done. There's no like terms in here. I got a 4th, a cubed, and a squared, so no like terms. Number 13, let me distribute, remembering to add your powers. So 2 times 3 is 6. A to the 2 plus 2 is 4. B to the 1 plus 1 is 2. Now go to your next term. 2 times 6 is 12, so I got plus 12. A to the 2 plus 1 is 3. B to the 1 plus 2 is 3. Last term, plus 10. 2 plus 1 is 2. B to the 1 plus none, so just plain old B. And then one last one. I'm going to distribute again. So I got 15. A to the 1 plus 2 is 3. B to the 1 plus 3 is 4. Minus 9. A to the 1 plus 1 is 2. B to the 1 plus 1 is 2. And then the last term, plus 21. A to the 1 plus none is 1. B to the 2nd. And then stop. There's no like terms in here. So you can't keep going. So you're all done. So you missed a pretty tough day. The concepts aren't hard, but there's a lot to them. So you got a worksheet to work on. So good luck to you.